Jai Hind students, I am Dinanath Prasad, Department of Electrical and Electronics Engineering, going to discuss about the transmission and distributions of electrical power system 1. So, this is very bright topic of transmission and distributions. So, in this topic, I will cover 2 points. First one is the structure of the power system, how the structure of the power system are defined, and another one is single line diagram of the power system. So, coming to the first topic, a structure of power system. So, basically power system is a structure on 3 parts. First one is generations, another one is transmission, and third one is the distribution. So, this generation, transmission, distributions as been shown in this by some color, like generations we represented by a red diagram. This is the generations inch. Second one, a structure, this is, let's suppose this is number 1, this is number 2, this is the part of blue line or blue color. This is showing the transmission side or transmission end, and third one is the distribution end. So, after further classifications, transmission line or transmission system we classified as 2 way. First one is primary transmission. This is primary transmission and the secondary transmission. And if we're talking about the distribution side, so distribution side is also classified as 2 way. First one is the primary distribution and the secondary distribution. So, coming to explanations of each part, like first one is generations. You can see by red diagram, generations basically we generate at lower voltage side. Generally it is taken as 11 kV voltage. And what will be the sources? So, sources of the generations, we know that our generations, how to generate power, that is some sources, that sources we known as renewable energy sources and non-renewable energy sources. On another word, it is it can be say this is conventional energy sources and non-conventional energy sources. So, this part for the generating stations, there will be any kind of power stations, through that we can generate the power, but this is taken to be kept in mind. The generations voltage we generate at lower voltage on the range of 11 kV. Now, there is some transformer. This is transformer. With the help of transformer, we can step up the voltage to the transmission level or for the primary transmission. So, in a primary transmission, the range of voltage is quite higher comparing to the generation side. The voltage range of the primary transmission will be very high. You can see on the range from 132.8 kV to the 765 kV. So, in primary transmission, we generally taken for the larger consumer, larger load side. So, they may required up to the 765 kV range. For the large consumer, like very big industries, we provide this range of voltage. Another is the secondary transmission. There is again we use a transformer. Through that we can step down the voltage on the range of lower voltage side on the range of 138 kV or 132 kV on the range of the secondary distributions, means somewhat lower load or lower consumer as comparisons to the primary transmission. So likewise there will be a distribution side, that is third number. There will be distribution, that is primary distributions and the secondary distribution. This primary distributions and the secondary distributions is also classified based on the loading, what kind of consumer is it. So in a primary distributions, the load or consumer or the to be use consumer having higher load comparing to the secondary distribution. So you can see in the primary customer or consumer, there will be range of 13 kV and 4 kV range. This is the range of primary distributions or primary consumers to be consume the power. And on the secondary side, there will be a consumer like which can take load as a single phase, or they can be operated as a 3-phase load. So accordingly, they will be 120 volt for the single phase. For the 3-phase, it is to be 240 kV. Note, this is the range of single phase. We can 3-phase 420 kV consumers are there. So this structure of the power system is drawn in this diagram. You can see that on the generation side, the generating source will be anything like large generator. They can be thermal power plant, hydro power plant, nuclear power plant. They may be renewable kind of power plant, they may be non-renewable kind of power plant. Again, you can see this can be generated at the lower voltage side, and that with the help of transformer, we having transformer. Through the transformer, we can step up the voltage according to the use. So you can see there is a step up transformer. Through that, we can step up the voltage. So a step up the voltage on the range of this primary transmission. Primary transmission, you can see the voltage range will be 400 kV and 200 kV range. Again, with the help of a step down transformer, we step down the voltage to the level of secondary transmission level, that is called sub transmissions, also on the range of 132 kV and 66 kV. So this is dependent upon the consumer to consumer. They are having very large consumer. They for this range, there will be large consumer or large industries. Then the last step, that is the distribution side. So this distribution side may be primary distributions and the secondary distributions. So primary distributions on the range of 11 kV, 33 kV or somewhat low, and the secondary distributions, they will be as a primary single phase load consumer or 3-phase consumer, like 3-phase consumer 400 volt or 420 volt, and for the single phase load 230 volt it is. So accordingly, they will be classified. This is the basic structure of the power system. Now come to the next important topic, single line diagram. What is single line diagram? Why we draw this single line diagram? So single line diagram is a basic representation of power system in various easiest way, and that will be classified, or that will be represented by some simple symbol. That symbols will be maybe IEEE standard or American standard, they will be defined. So this single line diagram of power system is the network which shows the main connections and the arrangement of the system component along with their data. Their data is also given, like what will be their voltage rating, what are their output rating, what will be the component, like they having resistance, reactance component, what are the voltage rating, what are their groundings. These all data are provided in the single line diagram. So you can see this is one of the simple representation of a single line diagram. In this diagram, they have been taken as two bus system. Let's suppose this is bus number 1, this is bus number 2. We have two bus system. One is they have been classified as a 3-part, like we classified the structure of the power system. First one is the generation side, this is the transmission side, and the this is first, you can see, this is second, and this is third part. So first part is for the generation side, second part for the transmission side, and third part is the distribution side. So in the generation side, you can see there is a generator. So in according to IEEE standard, generator is represented by simple like this. This is the simple representations of the any rotating machines. There will be there is a difference between all rotating machines. Maybe generator, there will be motor. How to differentiate this is generator or there will be motor? They will be represented by simple the symbol, what their symbol. So be represented by this generator, and this is the connection which is shows the how the generator will be grounded. So you can see the generator will be grounded through a star solid a star reactance grounding. This is the representation of circuit breaker. This is simple represented of bus. This is again a circuit breaker. This is the transformer. Obviously this is generation to transmission side. So this is a step up transformer. This is transformer 1 is taken as a step up transformer. Their grounding will be done as a delta a star solid grounding, and there will be transmission line in between the transformer 1 and transformer 2, and this transformer 2 obviously this is a step down kind of transformer. A step down transformer will be grounded as a star solid grounded delta. Then this is transformer 2 is directly connected to bus number 2 with and bus number 2 is connected to the distribution end. In the distribution end there is a motor, and this motor is grounded through a star reactance grounding. So this is the simple representations of any power system that having the two bus system. They are having one generator, one motor, one transmission line. These all system, that is this is 3-phase system. Basically we can represent it in a single line diagram in a various easiest way, and this single line diagram we represent all component of the power system can be represented by this diagram. This is the one of the various very useful point or very indicated point in any power system, complicated system, any vast power system we can represent by this simple diagram. Moving further about the impedance diagram. First of all, I will discuss here how to impedance diagrams drawn in the power system from the single line diagram. So with respect to previous single line diagram, how to represent like we having one generator. So in a impedance form or impedance diagram form, generator or any rotating machines we represented by EG. For the generator, if there is a motor like this is motor, we represented by EM. So any rotating machines in a impedance diagram we represent a voltage source for generator in series with the resistance and the reactance. Simple. This is the representations of any rotating machines. Now come to the transformer. In our case, we take in a single diagram we take two transformer, like one is a step up transformer, one is the step down, one is a step up transformer, another one is a step down transformer. So for the case of transformer, it is represented by simple equivalent circuit of the transformer. Like in this, this is the transformer 1, this is the transformer 1. We represent it by equivalent circuit diagram. This is the shunt path, this is series path, and on the secondary side you can see this is the reactance, this is the resistance. So this resistance and reactance can be represented by any side, or the primary side or secondary side, as we know, generally we know, we have studied already in the transformer equivalent circuit. Now come to the second part, that is the transmission line. So we always represent transmission line as a pi model. We know that transmission line can be represented as a nominal T or nominal pi. So in a impedance diagram, always we represent transmission line as a nominal pi diagram. Now again, this is a transformer 2. This is transformer 2 is simple like transformer 1, like, and the last one is the motor, that this is the same like a generator. This is a rotating machine. So this is, this way we can represent, or we can represent any impedance diagram from the single line diagram. So where it is used? So this impedance diagram is generally studied for the unsymmetrical fault. So in the we'll be talking about the representations for unsymmetrical for any circuit, any component of the power system. We drawn positive sequence network, negative sequence network, zero sequence network for the power system studied. If it is, but we take single line diagram study for the balanced system, balanced conditions case of system. So in the balanced case of system, we only represent on a positive sequence network. So this is the positive sequence network of the impedance diagram. Similar way, we can draw it as a negative sequence diagram and the zero sequence diagram for the fault analysis, for the any unsymmetrical fault analysis, how it is working. Now moving on to another very important part of the single line diagram, that is reactance diagram, or the power system, how reactance diagram will draw. So you can see in this here, first of all, how to draw reactance diagram. So reactance diagram, in reactance diagram is generally studied for the short circuit analysis. So in short circuit analysis, what we do, you can see in this diagram also, we neglect our series resistance, and another way we all neglect the shunt path reactances. All shunt and the series resistance will be neglected, that is winding resistance will be neglected, magnetizing resistance will be neglected, reactance will be neglected, on the shunt path completely neglected while the drawing of the reactance diagram. Reason being that the winding resistance include basically the line resistance, which is quite small in comparison with the leakage reactance, and the shunt path, which is include the line charging and the transformer magnetizing circuit. It is provide to high parallel impedance with the fault. So this is the reactance diagram, and this gives the very accurate result in many cases in a short circuit studies, or many various kinds of a study. So that's why we can draw reactance diagram and impedance diagram from the simple any single line diagram of the power system. So now come to advantages. What are the advantages of single line diagram? You can see it is helps to identify when to perform troubleshooting and simplifies the troubleshooting process. We can, any kind of troubleshooting will happen in a power system, we can easily eliminate with the help of a single line diagram. In any power stations you will find single line diagram, just they are representations of if there is a fault, any problem, they can be easily identified and easily can be there any kind of disturbances can be eliminated with this diagram. Another advantage, it is accurate single line diagram with will further ensure the safety of the personal work. This is very important. Another, meets compliance with the applicable regulations and the standard. It ensure safer and more reliable operations of the facility. So these are the general and more important advantages of the single line diagram. Now come to summaries of this lecture. So we can know that electricity is the most preferred use of energy in industries, in a home, business and a transportation system, and it can be easily and efficiently transported from the produced center at the point of use. It is highly flexible and it is used, can be converted to any desired form like mechanical, thermal, light, chemical, any kind of system. It can be conversion from the any system. So electrical power system is made up of many components connected together to form a large complex system that is capable of generating, transmitting and distributing electrical energy over the very large area. So with this summary, thank you to all.